Well, looks like it's officially time to start. Welcome, everyone. There was some concern about my labs. Evidently, I did the same thing to both classes. I set the due date for Thursday instead of for today. So if you didn't yet do it, it was open, I think on late last week. Anyway, it's been open a long time. It was due today. Should have been due today at 3:45, but evidently I missed that due date up. So yes, there was a MyLab math due. Yes, it's been open for a long time. Hopefully most of you got it done. It was fairly short. If not, make sure you do it before Thursday. There will be another one for Thursday. I've been able to automate a lot of stuff on Blackboard, and it just sort of hit me as I was writing these quizzes that I could automate the release dates on pretty much everything. So that's what I've done. That's going to make our little Tuesday to Thursday transition go a lot smoother. So when the last 10 minutes of this class roll around will be the quiz, and make sure, again, you know how to use the equation editor. I've been checking through my first class, and for the most part, they've caught on. There's still a student or two who is typing in long answers using this for power, and it looked really ugly, and when it's definite integrals, it's nearly impossible for me to grade. So make sure you do find that equation editor on today's quiz. Again, that'll open the last 10 minutes of class, which makes it, 4:50? That opens up 4:50. At 5 o'clock, the new video guide, the new MyLab math, and also I was able yesterday to finish up the newest activity. So all those should be available on your Blackboard page today at 5. That'll give you a nice, almost 47 hours and change to make sure that that's ready to go for the next class we have on Thursday. I will, as always, have my review session on Wednesday, and let's just keep it at 3 o'clock. That seems to be a fairly convenient time for me and convenient for a number of you as well. And if you can't make that, of course, it's always video. It's always recorded on YouTube, so you can always find it later. In the first class, we were able to get through pretty much all of the material that was on this activity. So if you have any questions on this activity, I'm ready to take a look at them. If you just want to work through it at your leisure, hey, that's fine too. I'll stick around for at least an hour or so, and then turn you loose at least with 10 minutes to go before the 5 o'clock hour. I did, by the way, if you're worried about timing of things, I have all this stuff down on Blackboard of nice flow. I guess it'd be a table that shows what's due each day when the test is coming up. Whoever question one, sure, Matthew, let's take a look at question one. In question one, we're given some information about how quickly the cars are coming off the assembly line. Function looks something like this, and I think it was the first 36 weeks. Take a quick look at that activity. There's 40 weeks. So this is the this is the production rate. And this is cars per week. It looks like at the beginning we're making 175 cars per week or so. Cars per week. At the very start, at the end of the first week, we're doing a little better. And then this is the number of weeks of production. So we sort of have to be a little cautious about how we number these weeks. If I ask how many, what's the cars per week for the first week? Here's the first week. It starts at 0 and ends at 1. So week 1 starts at 0. Week 2 starts at 1. Week 1 starts at 0. Ends at 1. Week 2 starts at 1, ends at 2. Okay, so that's sort of the counting is off just a little bit. I want to make sure we're really clear about what weeks we're speaking of as we go through this. So week 40 starts at 39 and goes through 40. So there's the end of, I guess, this would be the end of the first week. There's another way of looking at it. These numbers result at the end. There's the end of the first week, end of the second week, end of the 40th week. Okay, so with that little glitchy thing out of the way, and that happens often when you start, anytime you're counting something, the first week is going to be the beginning, and that's have a counter of 0. So there we go. So there's part A. Part B, find P of 31 and explain what it means in a sentence. Well, now we're back to the stuff we did right off the bat. So someone calculate for me P of 31 and then explain to me what exactly that means in a sentence. I'll write P of X up here. That way I have it for later. So part A, find P of 31, explain what it means. What does it mean? It's part A, part B. Yeah, put 31 in here, that's 32, 5th root 32 is 240, yep, that's 300. It's definitely 300. What does that 300 represent, Matthew? By the way, you can look at it right here on the graph if you want. And let's make sure we get our 31 well defined. Yeah, it is cars per week, but what week? What week are we talking about? Yeah, we're definitely producing 300 cars per week, but when? It's sort of not in week 31, but this is the rate of production at the end of the 31st week. Or remember, this counter is off a little bit. That would be the start of the 32nd week. So that's at the end of Friday, when we close the plant down, our production rate is about 300 cars per week. Or when we pick up production on Monday, our rate is right at 300 cars per week. So I don't think I want to write that out. I'll just dictate it. At the end of the 31st week, the production rate was 300 cars per week. Or at the start of the 32nd week, well, however you want to word it, it doesn't really matter. Okay. And it wasn't necessarily increased to, it just was. We start thinking about increasing and decreasing. Then we're talking about the first derivative and how quickly the number of cars per week is going up. And it's certainly continuing up as we go through the 40th, through the end of the 40th week. So at the end of the 31st week, our production rate was 300 cars per week. Seems right. And I try to make as much sense as possible and line up to how things work. And I've always been interested in vehicles. Tesla's the newest model out here. This is sort of their idea of how their ramp went on some of their vehicles. They started out manufacturing a few, and then as the weeks go by, they got more and more efficient. They keep opening new factories, and this curve sort of repeats over and over on itself. Although I think lately the curve has been a little bit steeper. It takes a little while for them to get going. This is maybe a little shallow at the beginning. All right, on to part B. Or I guess it's on to part C. On to part C. What what does that represent, the context of the problem? So here we go, 4 to 20. Here's our production rate of T, dt. So in words, what does that measure? If you want to tell me what that measures on the graph first, that would be fine as well. It's nice to have both the idea of what it is visually on a graph and then also what it means in the context of the problem. So if anyone in here wants to offer help on either of those parts, what this means as far as the graph is concerned, how you could relate this to something on the graph, and then what this means as far as the production of cars is concerned. Not exactly a sentence, put it in a sentence form. So what do we have for part C? Either what does this represent as far as the graph is concerned, or what does it represent as far as our production of vehicles is concerned? Yep, 4 and 20 represent the week. So this would be from the end of the 4th week through the end of the 20th week, or from the start of the 5th week through the end of the 20th week. So the 16-week long interval of building cars. That's definitely true. Yep, the quantity of cars, exactly right. Because if you look at the units here, these are cars per week, and these are the number of weeks. If you look at one little rectangle, it's maybe one tall and one wide. Well, let me look at the graph. Let's see what we have for the units on the graph. Yeah, that's 50. So let's say this is 50 cars per week tall. And then, let's see, I guess it's 2 wide. Maybe we should make it look a little square. 2 weeks wide. So if you have 50 cars per week multiplied by 2 weeks, every little square under that curve is going to represent 100 cars manufactured. This is the rate that they're manufacturing, and that's the number of weeks. So every little square on that grid represents 50 times 2, represents 100 cars. So the area under the curve always has units of whatever these are multiplied by whatever those are. That's universal. And as soon as you get that, all these applications just fall into that. That's the one big thing, the takeaway that you really need here. We have a little bit of an advantage this semester. Typically, I give the test right after this information, and sometimes this doesn't go quite as well as what I want it to. You'll have the advantage this time of spending an extra couple of days on it. We're going to do area between curves. There's some applications like this as well, so that we able, maybe, hopefully by the time next Thursday rolls around, we're able to just fly right through these. So that's the number of cars produced. Number of cars produced. Put it in a sentence form, please. From end of week 4 to end of week 20, or from the start of week 5 through the end of week 20. I don't know if you want to say it that way. That would be fine as well. Remember that this is the end time or the start of the next week. So now we need to find how many cars were produced during the first 32 weeks. Well, we talked about here, this is the number of cars produced from 4 to 20. And if you wanted to shade that region in, 4 to 20 would be that shaded region. Now we're interested in how many cars were produced for the first 36 weeks. So that's right out there, 36. What are you going to do to figure out how many cars were produced during that first 32 weeks? Give you a little hint here. The antiderivative is given. Should have been a big giveaway. Okay. So how am I going to calculate the total number of cars produced in the first 32 weeks of production? Oops, I'm sorry, it's first 36 weeks. What mathematical expression would give me that first off? Then how do I calculate it? That's the second one. And on today's quiz, I'm asking you for a mathematical expression. So how would I write that? Plug in 32 and 0. Yeah, but you have to do something first, man. You have to take the antiderivative. So we're looking for the area under the curve from 0 to 36. And perhaps you surmised that already, but it's the antiderivative of the production function. Oh, I forgot. So that's 60 plus, was it 120? Times t plus 1 to the 0.2 dt. So we want the area under the curve from 0 to 36. Exactly right. So now that we have that, we're going to do the antiderivative first. Just double check my formula. Right. Get back to 60, 120. Yeah, that was right. So we take the antiderivative. Notice that the power increases by 1 and we're dividing by the new power. So 60t, the antiderivative of 60 is 60t plus. We keep the t plus 1, raise the power by 1, multiply by the reciprocal of that new power. That's what makes that be 100. Now we're going to evaluate that from 36 to 0. So someone here tell me what that number is. The other half of you figure out what you get when you plug in 0, and then we can figure out the total number of cars produced in that 36-week period. That's week 0, week 1 through week 36. Guess I could do the 0 part, that's easy. Plug in 0, that's 0. Plug in 0 here, get 1 to the 1.2, that's 1. So that's 100. We plug in from 0. And by the way, my early class, the 215 class, totally blew off that 100 at the end. Just because there's a 0 there doesn't mean the antiderivative is going to be 0. Yeah, 8560 seems right. Let's go run to the nearest car. 8561. So how many cars are produced during the first 36 weeks? Looks like it would be 8461 cars produced. Nice. So it's area under the curve. On the graph, what would represent the total number of cars produced week 5 through 8? Well, that would be the area under the curve to week 8. So if you want to shade that in, I have a green marker. There it is. So it'd be that region right there, shaded in green. The area, I should go back. It's the area of that region shaded in green between 5 and 8, from week 5 through week 8. Yeah. Oh, wait a minute. In weeks 5 through 8, week 5. There we go. I screwed it up. Week 5 starts with a counter of 4. So there's week 5, right? Week 1 goes from 0 to 1. Week 5 goes from 4 to 5. So there's 4. Week 5 through 8 is an integral from 4 to 8. Whoops. Hope I didn't screw that up on the 215 class. I don't think I did. I remember backtracking. Find the average production rate. Okay. So here's where there's been a little bit of trouble with the understanding on this average production rate. So I'm going to go through that on this problem, and more than likely on the next couple as well. And we had some information on this on the last activity. There'll be more on the one coming up. So I'm going to erase everything I have here. And first off, I want you to tell me, what is the average production rate? We know how many cars were produced in that 36-week period. There were 8,461 cars produced. So you go up to 40. We're only interested in the first 36 weeks. There's the first 36 weeks. The area under this curve, draw that in and stretched black line. The area under the curve represents that 8461 cars. Okay. What's the average production rate? Well, we produce this many cars and we produce them in 36 weeks. So what would the average production rate be? Oh, it's 32 weeks. Ah, thank you. Oopsie. Now let me go back and look at that one. I've been messing up, haven't I? Yeah. So when we did, part D, that was 32 weeks, right? Good catch. Thank you. In the first 32 weeks, we produced this many cars. What would be the average production rate? First time I've been warm all day. Get 264.41 exactly. Divide this by the number of cars, or by the number of weeks, divide that by 32, and you get about 264 cars per week. 264 cars per week. Notice the units here. Is this many cars, this many weeks. The units are cars per week. That was the equation that was graphed there in the beginning. So my average value for my function has the same units as my vertical axis. It always does. Okay. Now I'm going to graph that, and that's going to be a nice, easy graph. And then there's something else I want to show you on this one. Find the average production and represent this graphically. Okay, 264, so that would be right about there. There's 264. Here it is. So what that average does is it sort of evens out the high and the low. It's not the biggest plus the smallest divided by 2, but it's the amount of area that's in this rectangle. This rectangular area that I just drew up here, that has to be the same area as the cross hatched as that thing is. They have to have the same area. So what I can do on this is I can approximate this really well. I look at this and I realize that I'm going to crosshatch this from upper right to lower left. This chunk here, where we're producing more than average, that area right there has to be the same size, has to be the same area as this production lag over here where we're producing less than the average. So that's how you get that average line in there. And if you don't have the function, that's sort of, you're just going to sort of eyeball it. Okay. So it makes sense that the average has to be somewhere between the max and the min, duh, of course. But in order to get that graphed in there, it'll be right at the spot where the overage and the underage balance each other out. Okay, find the production rate, and we did it. And the units here are cars per week. Right. And the average makes perfect sense, right? We did this many cars in that many weeks. Find the function used to calculate the number of cars produced during the first X weeks. Okay, so that would be the integral from 0 to X. There's the first X weeks. The first week is 0 to 1. The first 2 weeks is 0 to 2. The first X weeks is 0 to X. The antiderivative of 60 plus 120 t plus 1 to the 0.2 dt. And you could write that and you would be almost right, but I'm asking for the function. So let's go a couple of steps further. Let's do the antiderivative and then plug the numbers in. Well, we had the antiderivative before, and we've already plugged in the 0, so there's not a whole lot more we can do. But let's get it in an absolutely perfect, safe footing. Antiderivative, as I mentioned before, was 60t plus 100 times t plus 1 to the 0.2 power. Oh, I'm sorry, to the 1.2 power, we raised the power by 1. Now we're going to evaluate this from t equal to x to t equal to 0. And I remember what I got when I had t equals 0 before. If I plug in 0, that's 0, and this is 100. So this is 100. And when I plug in x, that's easy enough. It's just a function. It's 60x plus 100x plus 1 to my same power as I had before. So my production would be number of cars. We'll go C of x with the number of cars. That's going to be 60x plus 100 times x plus 1 to the 1.2 minus 100. Okay. So if I want to figure out how many cars were produced the first week, I plug in 1. If I want to figure out how many were produced the first 10 weeks, I plug in 10. If I want to figure out how many were produced the first 32 weeks, which I already know, I plug in 32, and I'd have the same number I had before. So we can take this partial information and really build back the whole function if we choose to. And there it is, problem 1, A through G. And I spent a little more time with this one in this class than I did in the other one, because last time we started on question 2. So some of the base ideas were built in before we got here. But this is really from the start to the end. And now that we have the base ideas with how you calculate the average, what it means graphically, and how the units work, that makes the rest of the problems on this go a little smoother. Part D was 0 through 32, I'm pretty sure, Brian. Let me check. Yep, 32 weeks. I have it right in front of me. Yeah, so both part D and part F are the first 32 weeks. Yes. Number 3 it is. So number 3, I've stripped away everything as far as the function is concerned. And I'm just looking at a graph and seeing if we can make sense of what that graph is showing us. Well, just like on question 1, it gives us a rate on the vertical axis. Problem 2 is different in that respect. Problem 3 gives us the rate. It shows us how hard the snow is falling. I think I wrote this 2 years ago as we were going into exam number 4 in my spring class, and it was just snowing like crazy a couple nights before the exam. One of those not atypical April snowfalls. I'm going to try to reproduce this graph in a decent manner. So there's where it started snowing. So there's the 0 hour of snowfall. There's the first hour. Looks like it peaked up a little bit before the first hour started coming down like crazy. Then it slowed down a little bit. And it's starting to turn the corner. Ramped up some, not as much as it was before. Little downturn. Pretty heavy snow there toward the end. Almost died out, and then a little kick at the very, very end. So there's the 6th hour. So this is the number, this is the snowfall rate, and it's measured in inches per hour. So here in the beginning, there's no snow coming down. Here at the 1 hour mark, there's quite a few inches per hour coming down. You can see the flakes coming down. One's up, big, light, big, and so forth and so on. So let's see if we can understand this from the very beginning. So we have 1 through 6. And then we have inches of snowfall. We peaked out just a little bit below 3. So this is inches per hour. This is the number of hours since the snow started. So if you were to take a box on that grid, each box is 1 by 1. This is 1 inch per hour, and this is 1 hour wide. So each of those boxes, each of the areas in those boxes represents 1 inch per hour multiplied by 1 hour. Hour units cancel, represents 1 inch of snow. That's what the area under the curve is going to represent. So we want the mathematical expression that will find the total snowfall during the first 6 hours of the storm. Well, the number of inches of snow is going to be the area under this curve. So what mathematical expression is going to allow us to find the area under that curve? Type it into the chat box, please, as best you possibly can. I had someone from the last class who was, I'm not sure how, but somehow managed to get an integral sign on one of these questions. That was pretty good. So what would be the total snowfall for the whole 6 hour period that's represented in the graph? You can type words in if you want to. I'll translate the words. What mathematical expression would represent the total snowfall for that 6 hour event? Or visually or graphically tell me what it would be. Yep, definite integral for sure. Exactly right. So get a definite integral from 0 to 6 of whatever my snowfall rate T is, accumulation of T, dt. Exactly right. It also be represented as the area under the curve. And there we have part B. Now this will give you the total snowfall in inches during those first 6 hours. Part C, I believe they asked for the average, it was me, I wrote this. Sorry, I guess this was part A, wasn't it? On part B, I want the mathematical expression that would find the average rate of snowfall. So this is how many inches of snow we got. How am I going to find the average rate? And here's all of my different rates from hour 0 through hour 6. Sometimes it's snowing at a rate of almost 3. At the beginning, it wasn't snowing any inches at all per hour. It was the rate was 0. Sort of had some peaks and some valleys. It dropped a little bit below 1 here. I guess that graph isn't perfectly accurate. It dropped a little bit below 1 there for a while. Up to 2, back down to 1 3/4, up to a little bit over 2, down to almost 0. Drop this down a little further, I guess. Finish off right there. So what could I do to find the expression? This is how many inches it snowed during the whole 6 hours. What would be the average rate? What would I do? Yeah, 1/6 of the definite interval, sure. So I'm going to take this number of inches per hour. I'm sorry, this is the number that snowed. I'm going to divide it by 6 hours. So 1/6 of 0 to 6 A of T dt. There would be the average snowfall rate, right? Again, this right here is going to be the number of inches. And then we're going to divide that by 6 hours. I don't know precisely what that is because I'm not given the formula here. I can get an estimate of it, but that's as good as I'm going to be able to do. And I think that's what the rest of this question asks me to do. Estimate the total accumulation for the first 6 hours of the storm, and then on average estimate how hard it was snowing during the first 6 hours of the storm. And I'm going to do this backward because it's easier. So if I did this forward, if I did step C next, what I sort of try to do is count up all those little blocks. And there's just so much darn estimation between, some of this blocks is about 3/4 of a block, some is about half a block. And it would be really hard to count the blocks and figure it with any accuracy whatsoever. So what I'm going to do is I'm going to calculate the average snowfall rate first. So I'm going to try to draw a line across here that evens out all those peaks and all the valleys. Now it's not the top and the bottom that split the difference. It's the line across here so that the area above this line and the area below the line and above the curve are pretty much evened out. So I'm going to try to strike a line in here someplace. And my graph here isn't perfect, so I'm not sure. Probably if I looked at the other screen, I could estimate it a little bit. That's probably a little too high because I look at those two are about the same size. Those two are not going to fill in that big hole at the bottom. So I probably have that a little too high. And when it comes time to do one of these on an exam or on a quiz, I'm not going to, if you're off a little bit, I'm not going to bust you too hard on that. This is probably a little better. So it looks like this area is a little bit less than that. Those two are a little bigger than those two areas, but I think that's right about where it should be. So what should happen is this area in this rectangle right here, in my rectangle right there, that area should be the same as the area under the curve. Miniature version of this over here, the area under the curve looks something like that. So those two areas should be the same, okay? So there's the average snowfall rate. Again, I'm going to estimate that average snowfall rate is about 1.5 inches per hour. Again, I'm taking this curvy line and I'm replacing it with a flat line. The curvy line, this function right there, has units of inches per hour. It's the rate. This is the average rate. It still has the same units. I'm replacing this curvy line measured in inches per hour with this horizontal flat line, again, measured in inches per hour. So if I look at this big rectangle, it is about 1.5 inches per hour tall and 6 hours wide. Okay, so if it snows on average 1.5 inches per hour for those 6 hours, it looks to me like that whole snowfall event was 9 hours. It was about 9 inches of snow. So again, it's much easier, in my opinion, it's much easier to strike that average line, do part D first, and then go back and get part C. But part C, if you want to try to estimate how many squares you have there, yeah, that works as well. Make sense? Any questions on problem 3? So one more time, when you're looking for the average function, it has the same units as the original graph had. The area under that curve has to be the same as the area under the curve that has area under, I guess, the rectangle. The area in that rectangle has to have the same as the area under the curve. Units of area. The basics of the the definite integral. Units are always these units multiplied by those units. These things never change. And as soon as you get that down, the easier this work is going to be. Well, no, it's definitely the accumulation. It was never snowing 9 inches. The hardest it was ever snowing was what, just about 3 inches per hour, if I look at that? Let me go back and look at the graph real quick. Yeah, right after the snowfall started, right before hour 1, maybe 45 minutes into it, the accumulation rate looked to be almost 3 inches per hour, and that's as hard as it was ever snowing. Okay, so it didn't snow 3 inches per hour for a long time. It averaged about 1.5 inches per hour, 1.5 inches per hour times 6 hours, so 9 total inches of snow. So how hard it was snowing is represented by the squiggly line. The area under the curve is the total accumulation. Those are just excellent ideas to get cleaned up now. Because if they're cleaned up now, that's going to be really easy on the test. Really, I should be able to give you any function now. Doesn't matter what it looks like. Any function in the world, you should be able to find an average value over a period. So on this graph, I'm looking for the average value. Maybe this is from 0 to 900. Try my best to draw a line across here. And usually I have to do it with pencil first. try to get it so that the area in the rectangle is the same as the area under the curve. So the area of the overage is equal to the area of the underage. I think I did pretty good on that one. I think the area of this region would probably fill that hole. I can envision a bulldozer coming along and pushing it right in there and making sure that the land mass evens out. Okay. Might as well do number 2, I suppose. So I'm going to put number 2 up here. You're going to answer me step by step as I go through. This is how I did the last class, except for I think we ended on problem 3. I think we did 2, 1, and then 3. So I'm going to put each of these problems up here. You should have this down pretty well by now. We'll see. At least some of you hopefully will, and we'll work our way through this. Problem number 2. Problem number 2, we start with a function. It is the demand, electric power demand. Notice that this is the power. So we have power over here, and this is measured in gigawatts. I think it's, I think it might be this. GW, it's GW, we'll just write gigawatts. And this is the number of hours. Starts out a little low, electric rates in the evenings are low, wake up in the morning, we get a little bit of a ramp up. Peaks up, people leave for work, it dies down a little bit, they come home from work, turn on the lights, do a little cooking, and then it's the end of the day. So this was an October day in New England, October 22nd, 2010. Sort of even right back where it started. What does the area of the shaded region represent in the context of the problem? Okay, now before we get there, let's understand what the area under the curve is going to measure. This is power, and this is hours. I'm going to again remind you of how this works together. So say you're going to go out for a run. The power is going to be like how fast are you running? And then the hours is going to be a multiplier by it. So if you're sprinting, if you're at high power and you go for a set period of time, what you're using is how much energy. So the power times however long that power is applied, that's energy. Okay. Now so it's definitely going to use a whole lot more energy if you're sprinting versus if you're taking a slow jog. So the area under the curve in both cases represents energy. So this is power, but area under the curve is energy. And we had this same problem, only different units on the last activity. And energy is the area under the curve is always these units times these units. So energy in this case is going to be measured in gigawatt hours, not gigawatts per hour. It's a multiplication of these two things, not a division. Every single time there's an area under the curve, it is always these units multiplied by those units, always. Okay, so let's see, we have hours from 0 to 24, of course, because it's a full day. So the area under the curve, what does the area under the curve represent in the context of this problem? Write a sentence, include units. So who's going to answer that one for me? I'll maybe recreate the shading here while I'm waiting from 12 through 16. No, the power demanded is going to be this curve right here. The power at 12 o'clock was, that was about just a little over 15 gigawatts. The power at 16 hours was right at 15 gigawatts. So the curve, the red curve, I should have got my red pen here, huh? I don't see it anyplace. That red curve here is the power. Okay? The area under the curve is not power. So what is the area under the curve? So again, this is the power. the red curve here, that's the power. The area under the curve. Yep, it's the energy demanded from when to when, and what are the units, Brian? Okay, so let's put this, and these are hours per day. So let's say the energy used from, how about noon to 4 p.m. on that specific day. And what will the units be for that energy? Gigawatt hours it is. Good. Part A is in the books. On to part B. What does that definite integral represent? So it's a definite integral from 4 to 18. I'm going to jot it up here, that way I don't have to remember it. Oh, maybe I should get two computers up here, that way I can have one of them streaming. Energy used or energy demanded, it doesn't really matter. They're pretty much the same thing. It's the, yeah. So there's part A. On to part B. No, this isn't going to be a quantity of power, huh? The power is this red line there. Okay. A definite integral does not tell you what that line is, but the definite integral gives you what as far as a graph is concerned. What does the definite integral stand for? What is it? If I were to look at this definite integral from 4 to 18 of this function here, how could I represent that on the graph? Yeah, exactly right, Estonia. So it's the energy, again, it's the area. This gives us area under the curve. So we would go from 4 to 18 on this case, in this case. So it's the area under the curve. And just like the last area under the curve was the energy used for a time period, this is pretty much going to be the same thing. This is still the energy demanded or used from. And now let's change our numbers a little bit. This would be from 4 a.m. until 18 hours. That's what, 6 p.m.? But the measurement is still going to be the same, measured in gigawatt hours. So problems A and B are the sentences are pretty much the same. Now we have to make sure we make the connection of area under the curve is something, and area of the curve can be captured by a definite integral. So that's what I was trying to get by putting parts A and B right next to each other. So both of those are energy. Great. On to part C. What does that next definite integral represent? Answers in the chat box, please. What is this called? Yeah, live chat. Excellent. Now we just changed that to a 0 and that to an X. Heck, while I'm at it, I might as well shade this region. 0 to X. I'm not sure where X is. It's some random place out here someplace. It's really any X between 0 and 24. Energy used between 0 and X. All right, let's make that, this would be, here's midnight of the day, so it would be really the first, X hours of the day. So the energy used during the first X hours of the day. And again, they're going to be measured in gigawatt hours. We're not going to change the units. We're not going to change what it is. Area under the curve, in this case, is energy, always measured in gigawatt hours. So instead of saying from 0 to X, how about maybe from midnight till X hours after midnight? That'd be fine. I like this. This is a little more succinct. Measured in gigawatt hours for sure. Okay, so part D, would that mean the average energy used? Well, it's not going to be the average energy used. The average, again, we're replacing, I'm going to redraw this. The average function, or the function we're trying to average, is this power function. We're trying to take the hills and the valleys out of the power function in part D. And I want to make sure I have the right units here. 114, so it's 4 to 18. We did 4 to 18, that was part B, wasn't it? Okay, so again, here's my function, as best as I want to do it. And from 4 to 18, 18 was just a little bit before the big peak, right? Yeah, before it ran all the way up. So notice that this is a 14-hour stretch, huh? From here to here. So I took 1/14 of this 4 to 18 d of t dt. So this is the total energy. Now what I'm replacing this area under that curve with is a simpler line, or a simpler area, not a simpler line, a simpler area. I want to take off these peaks and these valleys. I want to come up with a rectangle that has the same area as this area under the curve was. So I'm going to sort of stretch it along here. Maybe that's the rectangle. That looks fairly close. That piece of area there would fill in that little valley. So that would be my average. So I'm replacing this curvy thing, and here's where we have to get the units right. I'm replacing this curvy thing, this power function, which dips and peaks and dips again. I'm replacing this with an average power function. Okay, so this is the average, not the average energy, but the average power. It's the same units as I have over here, measuring the same thing. I've just replaced this thing that has a bunch of curves, this power function measured in gigawatts that has these curves. I'm replacing it with a simpler line. So it's the average power consumption or demand from 4 a.m. till, what was that, 6 p.m. Yeah. And this is going to be measured in gigawatts. So again, I'm replacing this little segment of the red line with a line that balances out the peaks and the valleys there. So there's part D. Draw, oh, I did already. Oh, no, I didn't either. I drew the one from 4 to 18. Draw a line that would approximate the average demand for electricity for that day and estimate its value. Well, I have a graph up there that isn't perfectly accurate. So I'm going to try my best to draw one on here. You should probably grab a pencil, and I'll show you one more time what to look for to get that to balance. So we want the whole 24-hour period. Box this off here at the end. So I'm going to replace that squiggly line with one that evens out the hills and the valleys. So maybe go right along there. Extend it a little higher. There we go. That's where I ended the day at 24. And I think right now when I drew that one, I probably drew it just a little too low. I think the area up here overshadows that. I'm going to draw it a little higher next time. That's closer. I might go a little higher. But again, I don't have, this isn't drawn perfectly accurately. If I looked at that screen and drew a line, I don't know, right about 14, I guess. That would be my best estimate without wanting to write a permanent marker or a semi-permanent marker on my computer screen. So I would estimate that to be right about, and again, the units here, the average use takes care of the hills and the valleys. The hills and the valleys are measured in gigawatts. I would estimate the average, not going to bust you on that if you put it at 13.8 or 14.2. You start putting up here at 20, I'm going to say that's wrong. You put it down there at 10, of course, that's ridiculously wrong. It has to be so that, yeah, it's best you can do those areas balance. Make sense? Hopefully so. We'll have a few more of these to look at on, at least one more of these to look at on the activity on Thursday. And by the time next Thursday rolls around, hopefully all of the stuff we've talked about will make perfect sense. So again, go back, look at this a few more times, see if you can get those units to align. I don't think there were a lot of really great ones on MyLabs, but there were a couple. Oh, by the way, there was a MyLabs that I wanted to have due today. I put the wrong date on it for some reason. I put it due Thursday. So if you've not yet done it, make sure you have that done by the time class starts on Thursday. I will have opening up for you in about 4 minutes, the next quiz. I want you again to experiment with the equation editor. I got almost all my first class to use that today. I'm still a couple of them who haven't found it. So use that equation editor. I think most people finished it in 2 minutes. It's a fairly straightforward question taken directly from the stuff we've just got done doing and the stuff that was on the last activity, since pretty much these overlap each other. At 5 o'clock, I'm going to repeat this. I think I said at the start of the hour, we might have some different folks here. At 5 o'clock, the newest video will open on Blackboard. The newest video guide will open on Blackboard. The MyLab Math will open, and the latest activity that we're going to cover on Thursday. All that should open for you at 5 o'clock when class is over. So I sort of experimented around with that, and I realized that once I had everything set and ready to go, that I could just date this to open whenever I wanted to. And I'm going to try to keep that going the rest of the semester. That way, there's no chance for people to run out of time. You're welcome, Matthew. You're welcome, Ms. Stefania. And I will talk to you, I guess the next time that I'm going to be live will be tomorrow at 3 o'clock. So if you have any more questions over any of this or anything else, contact me then. Good luck on today's quiz. Again, that should open at 4:50, so just 2 minutes from now, providing I set the starter right, and I'm going to investigate that to make sure that you're all in. So talk to you tomorrow.